Welcome. Today I'm going to show you how to create a microservice with Meteor 3.0. We will use the latest release candidate, Meteor 3.0 RC.4, and create a bare project to have the most minimal installation a Meteor project can have. With that, you will be able to run a headless or clientless Meteor microservice that allows external Meteor apps or other apps to connect either via DDP and call RPC style endpoints via Meteor methods, or use HTTP based transport to call express endpoints. For that, you simply go to your project, open your IDE, and create a new one via Meteor, create --bare, that will be the bare project, --release 3.0 -rc.4 to use the latest RC. This is very soon not required anymore because then the final Meteor 3.0 release will be there, right? And then give it some nice name. Then Meteor will use the bare skeleton to create a super minimal Meteor project. And just by taking a look into the folder, you can see this is really just the .meteor folder, a package.json, and nothing else. And in order to get anything run, we need to create an entry point first. This is usually done by Meteor in every other project automatically. But for this bare project, we have to do it on our own. That's not a problem. We just enter Meteor, then a new entry main modules with S at the end, and then we define our main module for the server. We call the path server / main.js, and we have to create that, of course. So I'm going to do that with my IDE, call the folder server, and then there's a main file in that server, and that's already enough to have Meteor known how to run these things. So we go into the folder and enter Meteor, then it would automatically run the project without any additional functionality on localhost 3000. And in the meantime, I'm going to check the versions here. So this is all the installed Meteor packages you have, and this is really the most minimal in order to run a Meteor project. And we could even shrink that down when we go to packages. There are lots of things we don't need here. We don't need the mobile experience. We don't need static HTML. I'm sure we currently don't need tracker and reactive variable. And we also don't need the shell server. I'm not sure if I can safely delete TypeScript because maybe some internal packages rely on that already. But it looks good so far. So let me quickly remove this as well. Looks good. No errors so far. So this is even shrink down to the most minimal setup. We will use Mongo because we want to have some DB access. And now our version shrunk down to 57 packages here. This is really good. So from here, we're now creating a high-level entry point. So how are we going to do that? We want to have two functions: shorten a given URL, returning a code, and of course restoring the URL by a given code. We don't want to do the redirect and things which a full URL shortening service does. This will be part of something else. This is just a microservice that just shortens an URL or returns a URL by the shortened code. So first of all, let me do some high-level work here, okay? I import the Meteor and the Mongo objects and create some Meteor methods. And we call the one method short, which takes a URL, and then returns something. Okay, and then we also want to have the function URL, which takes a code and also returns something then. Fine so far. Okay, but then we also want to have HTTP routes, because this microservice may not only interact with another Meteor application, but may also interact with some other applications that use HTTP instead of WebSockets and without the DDP protocol. So what we need to import as well is the so-called web app, which is a wrapper around Express. It allows us to define Express endpoints without the need to install Express and all that stuff. We use for that web app.handlers.get. It's the same as if we would say app.get if we have a native Express application. And then we say /short and request and response. This is the short route. And then we also want to have .get a URL route. Request and response. And that's our high-level API so far. Okay, so how are we going to implement this? First of all, why did I not implement straightforward within already the methods? Because we want to write one function and use it by Meteor methods and by the web app handlers. So in order to do that, I'm creating a new function called createShortCode, and we will have some MongoDB interaction. So it must be an async function, and it takes a URL, nothing else, and then it creates a code for us. So how could we do that? We could, of course, just create a hash for each URL, and that's okay. But what we want to do is we want to have one code for a given URL, and we want to store it in a collection this time, in order to later use the same code for the URL, and also for not being so predictable. Because if we are predictable, first of all, the hashes are very long, and then they're predictable, and maybe this is not what we want. So what we want is to first fetch a doc from a collection. Oh, there is a collection missing, no problem. Let's create a new Mongo collection. Const URLs collection is a new mongo.collection, naming URLs. That's fine. And then we need to get our document called URLs collection, find one async by the given URL. This is very important because we want to see if there is a code for this URL already, because then we just need to return it and don't need to randomly create a new one. So if there is no document, then we assume there hasn't been a code being generated for that doc. That's fine. So we create a new one. So the code is random.id, and I say the code is length of 8. And in future apps, we might check collisions here. But for now, this is fine. And we need to import that code, import random from meteor/random. And then we create a new document, await URLs collection, insert async with the given URL and the new code. And then we just create a new wrapper doc. That's fine. We don't even need to we don't need to do that. We just need to do that because in the end we just return doc.code. So this is what we return for creating a short code. But also checking if one exists, then we just return doc.code. If it not exists, we create a new one. And we can easily just use that and return it here, create shortcode by the given URL. And why don't I need any async here? Because this function will return a promise because this is an async function, always returning a promise. And returning a promise will make the caller resolve the promise anyway. For completion, we could also write this as async, and then could say something like const. We could do it like this. We could say return code, and then something like this. This would be even more comprehensible in the end, because we actually know that this response will contain a code. Let's keep it like that. That's okay. And for the web app handlers, we are going to do the same. So first of all, we need to get the URL, and here it's a little bit more tricky because we have to first request query URL. Let's first keep it like that. Let's first do it without any of these, and then we create again the code. This code is await create shortcode by the given URL, and then we return response.json with this as a code. This is basically the HTTP endpoint. And if we want to run this now, so let's restart. We can easily check this with using something like CRL. So checking if it's running. It's running. That's good. CRL -i HTTP localhost 3000 short, and then as our query parameter URL equals, and then HTTP //foobar.tld, and then it gives us a code with these letters. And we can also check, if we go into the project, we can also run meteor mongo from the command line. It will open the Mongo command line, and we can say db.urls find one, and this is actually the correct code here. And from there, as you can see, that this is the URL stored. So what happens if we enter a slash at the end of the URL, which occurs sometimes? It will create a different one, but the URL is basically the same. So how do we want to treat that? We could easily create some kind of an helper function to clean the URL. So cleaned URL, and then we have something like, let's say we check if the end of the URL, first of all, maybe we want to trim. So let's say let cleaned is URL.trim. This trims all white space from the start and the end of the URL. And then we could ask it, cleaned ends with a slash. Then cleaned is clean.substring from 0, the beginning, and cleaned.length -1. Then we have stripped the slash at the end, and then we return cleaned. So then we have our cleaned URL. You can use that here. So instead of the URL, we could say is cleaned URL this one. We can do the same here. Yeah. So then we have a clean URL and create a shortcode for both. So if I do that, it creates this one. Or first, let's check if it still needs to restart. So let's run this. Oh, now it returns the old code as we do without one. It's the same. It's basically treated as the same. And this can be adjusted to your needs That's totally fine. But now we have this code and we want to get URL back. And we can easily do that with a new function we call get URL. And then we have the code there. And what we need to do in this case is, of course, we need this time to find the document by code and not by URL. So let's see, doc equals await. It's an async function because we first need to await the URLs collection dot find one async by given code instead of URL, because we save, as you can see here, we save in the URL collection, we save URL and code, so we can search it by either of them. And then what we want to do is doc question mark dot URL. What does this do? This is basically checking return doc.url only if doc exists. If doc doesn't exist, it will return undefined. That's fine. This will prevent us from any bad things, so to crash if URL does not, if doc does not exist. What we want to do now is code equals request query code, and then we say const URL equals await get URL by given code. That's it. And then we return again a JSON, but instead with code with the URL. We can do a similar approach with the URL method in the meteor method. So in that case, we only return /URL await get URL by given code. Okay, that's nice. Oh, and it's not async, so we need to make this async as well. So that looks good. I mean, we're 50 lines here, 51 lines, but I mean, that's really tight. So let's use that code now. Let me copy it, and instead of this, we do the endpoint URL, and then code equals this one. I hope it's fine. Oh, and it returns the URL for me. And because we already saved the other URL with the slash here, it's already in the database. It will return this old unstripped version. And from here, that's it so far. And from this, you have already a fully functioning microservice. I mean, this is really, really micro, even nano. It just do two things. It resolves the URL into a code, and it resolves from a URL from code. And you can do lots of things with this. I mean, again, this is not a fully functioning URL shortener service, but this is like a foundation for such a service. And you can do now deploy this and connect this to any other apps, or use this code as a basis and extend it to your needs. Build a fully fledged application service out of this. Do whatever you want, and you have plenty of options to deploy this. You can use Meteor Galaxy, which you can use via Meteor deploy. -help gives you some interesting facts about what you can all do with Meteor deploy. Basically, it's the #1 hosting for Meteor apps, and there's also a huge guide out there how to configure it, and this is a complete own documentation section in the Meteor docs for using Galaxy. Comes with multiple tiers. There's even a free tier. They have in their new Galaxy, they have MongoDB automatic integration for this. You don't need an extra Atlas subscription anymore. And if you are really short on money, or you really just want to do some fun and experimental service, there's also Meteor app, which is also called MUP. It's typed MUP, M-U-P. You can download it from NPM and deploy to your custom infrastructure, whatever you have, your bare metal server or DigitalOcean droplet, or whatever you're gonna have. And with this, I'm finished with this little tutorial. I hope you had fun and you learned something today, and hope to see you next time in the Meteor weekly stream this week in Meteor.js on our channel. Please subscribe and like and check the channel out. Take a look in the other videos and hope to see you next time in the live stream. Goodbye.